We'll be showing how tubing makes a difference in delivering ozone. We'll be looking at materials, silicone and PTFE, also known as Teflon. We'll be looking at different diameters of materials. All are 36 inches long except for the last one, and it's 12 inches. So we have 1 millimeter internal diameter of PTFE, 12 inches long, and everything else is 36. So we're going to be checking each one at different flow rates at 1/32 liter per minute, 1/16 liter per minute, 1/8 liter per minute, and also time to peak. That is, as it ramps up from 0 to its peak, and we're going to catch it just as it hits there and then bounces back 1, and that's where we're going to take the time. It stabilizes after that, but that's the only way we can be apples and apples comparison. We'll start with a 4 millimeter internal diameter, but before we do that, let's look at all our component parts here in our evaluation. We have a stopwatch, and then we have an analyzer. We can zero that out with clean air. Okay, and then we have a generator, basically a Stratus type generator, oxygen cylinder, regulator that gives us 1/32, 1/16, and 1/8 liter per minute flow. We're going to be looking at different Teflons, or different tubings. 4 millimeter silicone, 1/8 inch silicone, which is comparable to 3.175 millimeters. That's the most common. And then we have 1 millimeter internal diameter silicone, so we can compare 1 millimeter with 1 millimeter Teflon. We're going to be testing both 36 inches, which is the same as all these, as well as a 12-inch segment of Teflon to show the difference between length and how that impacts flow concentrations as well. So let's go ahead and take a look and start our evaluation. We'll start with the 4 millimeters. Connect it to the generator. And our analyzer, put our flow rates on at 1/32. This wasn't dumped out, so let's clean it up quickly here and we need to flush all the residual ozone that was in here, and so we'll get it down to 0 here. And soon there. All right, now we'll go back down to 1/32. And we're going to go ahead and start our clock and our generator at the same time. 1, 2, 3, go. Now, while we're talking here, it's slowly traversing through this. It's very large volume at 1/32 liter per minute. It takes a long time to traverse. So while we're doing that, we're going to look at, again, going back, the next one we'll be testing is 1/8 inch diameter, which is most common. Although this comes with a package, you can see how it is at least efficient of all the tubing, at least what we have here. And then we'll do in 1 millimeter internal diameter silicone. What we're watching here is when the ozone finally hits this beginning right now, it hits it and it starts recording and it starts raising and it's diluted and it starts increasing its density until we finally get to a stabilized point. And that's where we're going to stop our clock at, when it hits the maximum level and starts bouncing back and forth. So we'll watch it carefully here. It's still on the way up, so as long as it's going up, but notice how long it's taking to get stabilized. So keep going until it stops. 3, 4, we're going to call it right there. So it's 99.4. And then it was 1 minute 13, but let's put it on 1/8 right now, 1/16 right now, so we know what the next one is. Meanwhile, we'll record 1 minute 13 seconds. 1, 1, 3. So that was to peak. And now we're starting to, it takes a while to get through here, so it's going to be a little longer. Now it's starting to come down. That little burp in there, that little extra boost, was when I turn the dial, it actually kicks up the ozone a little bit because it stops the flow. But now it's getting back to its 1/16 flow reading. and it's going to be, we'll call it 79.1. Let's turn it to the 1/8 flow, 79.1. 79.1. Now we're doing the same thing, hits that little burp, and then it'll get back down to 1/8 flow. The reason why it's lower numbers at higher flow rates because there's less molecules being energized by the electricity in there, so the concentration is less, but the flow rate is multiple, and so you get more ozone, but it's just at a lower concentration. This will stabilize at, looks like 57 point, we'll call it 5. Okay, so that takes care of the 4mm tubing. We'll let it flush out here. I'm going to turn it up a little bit so it'll flush faster. Keep the clock going. Reset it. So we're getting down there to 0. I'm going to turn this back to 1/32 liter. So we're ready for the next one. Take this off and this off. Put it aside. And then we go with our 1/8 inch, more common size. Connect it up. And plug it in. And let's flow some fresh air in there to get our zeroed out again. You'll see numbers there initially because it's got some residual ozone in there from earlier tests. So we're at 1/32 liter right now. We're 0. Let's run that one. Start. It's going to be quicker than the 4mm because it's like equivalent of 3mm, but it's still going to take a little while. And again, when it's getting through the tube, it gets all the way through here, and it starts coming up, and it'll hit pretty soon right in that area. You'll see the first. There you go. And then we catch it when it hits that peak. Looks like 100. So we'll knock it right there. At 40 seconds, it hits 100. Now let's go down to our 1/16. Remember that 100. 100. And then it was 40.72. We'll call it 41. And now we're probably getting stabilized. Reset that now. Stabilized, it looks like 80 point, we'll call it 80.3. Now let's do our 1/8. And that's going to be 58 point, we'll call it 58.0. Let's call it right there. Okay, so that takes care of the the 3.175 diameter. Let's turn off our ozone generator. Get oxygen through the line to clean out the analyzer. So it's down there, it's ready to go. So let's go back to 1/32. Remove our tubing, and we'll zero that again. Now we're going to do the 1mm diameter. You can see how thin this is, how flimsy it is, how easy it would be to kink and all that stuff. It's just not practical in a real clinical setting. Connect it. And we'll flush this tube out also so that we know it's clean. So we'll put ozone gas in there, or oxygen in there to clean it out. Okay, we're zeroed out now. Set it at 1/32. So 1/32, timer's ready to go. Let's turn on things. And 1, 2, 3, go. This can be faster, so we'll be right on it here. So it's zipping through this line, and it's already there. Let's see where it stabilizes. 106, 107, 108, 109. Looks like that's going to be it, so we'll cut it right there, 109. And while it's there, I'm going to remember that number, 109. 109. And the time was 19. And at 1/16, it is at 83.2. And let's go down to 1/8. You see how much faster it is with a fine line. It just zips through there and it gives us readings much more quickly, which means it's delivering the ozone more quickly to your application. 59 point, we'll call it 59.4. And we got the time already, so reset that. We're done with that, so let's turn off the generator. Flush out the tube. I turn up the oxygen a little bit to be a fast flush, and then we go back to 132nd. Remove this. And we'll put on our 36-inch long piece of Teflon. This one right here. Teflon is thinner and it's really strong. I'm going to yank on this, even yank on my connections, and it's really, really strong, durable. Nothing, ozone does not impact it whatsoever. And we'll flush it out again as well before we run our test. But it's still flexible enough that you can use it. It's not like it's so stiff that you can't use it. If you get thicker Teflon, it is stiff. So we're already zeroed out, so we're ready to go. We're on 0. Start both the generator and the clock at the same time. As soon as it hits our peak, we'll time it, but see how fast it is. They're already bumping up there rapidly. 120, 121. Let's call it right there, 120, and it was like 13 seconds. I didn't push this, it got up there so fast. So 113. See, 13 seconds, and we were, was it 119? I can't remember what it was. 119, I think it was. Let's run it again. Just, no, we're good. 119, and now let's turn it to 1/16. Reset this for the next test. So 1/16, we're at 84 point, we'll call it 85. And then now it's bumped up on us, but okay, 85.5. And then let's go to our next flow rate is 1/8. Let's call it 6.1. And now let's turn the generator off. Put this back to 1/32. Let's let it flush out first, then we'll go to 32nd. There we go. And then we'll remove the 130. We'll remove the 1 millimeter diameter, internal diameter Teflon tubing that's 36 inches long, and now we're going to put on the one that's 12 inches long, just to show you the difference in speed of everything with the 12 inches, 1/3 of the length of the other. Okay, make sure we're secured. We'll flush it out again. And turn on our oxygen, flush it out. Clock is ready. This would flush out seconds, okay. Very rapid because it's very short distance, very fine bore. Okay, so let's see. I didn't write down, I did write down, okay, it's just a different line. Okay, so we're about ready to go. 1/32 liter per minute. Clock is set and generator start. I'm going to be fast on this because it's going to be jumping up real quick. Or you got there. Okay, so it stabilized at 119 and 13.5 seconds. And 13, we'll call it 13. And then let's turn it up to 1/16th flow rate. Call it 85 point. Let's call it 85.9. Or 86, pardon me, 86.1. And let's turn up the flow rate to 1/8. And that is going to be 60 point, let's call it I'll call it 0.5, 60.5. Okay, so there you have it. So what we've seen here, now I put this 1 millimeter is up here, so all these go up one notch. I'm sorry, I was busy writing. So this goes there, and this one goes there. So I want you to look at the differences here. Let's compare apples and apples. 1 millimeter diameter silicone compared to 1/8. We had a peak of 1 meter, 109, and here is 100, and here was 99. So it's 10%, roughly 10% more production just because of the difference in diameter between 1/8 and 1 millimeter, 1/8 inch and 1 millimeter diameter. And then as you go down, it's the same thing. As this is higher, the smaller diameter, the higher the concentration is delivered. And that's really what it's all about. It's not what the machine puts out, it's what's delivered at the tip. So there's a difference here, especially in the upper end, is 10%. But now you change from silicone to PTFE, comparing 1 millimeter silicone with 1 millimeter Teflon, same length, 36 inches. This was a peak at 119, this peaked at 109. Again, a 10% difference just for changing materials. And then when we change to a smaller length, notice there's not much change. The Teflon does not interact with the ozone so much, so you end up getting basically what's put in there, you get taken out. Whereas here you see a depreciation, which I believe is some kind of a reaction going on, or some kind of impedance going on that's resulting in the changes here. But see how close these are, 119, and 85.5, and 86.1, and here how close they are. And here's the other thing about diameter. It shows how slow it is when the larger diameter, 1 minute, 13 seconds, 41 seconds, 19 seconds, 13 seconds, 13 seconds. Notice comparison between 1 millimeter silicone, 1 millimeter Teflon. There's a significant difference in delivery time. So something's going on between the tubing. Strongly recommend using PTFE Teflon. You see the numbers, you see the data. Well, it makes 10%, but 10%, if you pay to get 100 out of your machine and you're getting 90, and then if you're prescribing 100 and you only get 90, then things aren't really working the way it should be. So very important to pay attention to the materials that you use, the diameter of the material you use less. You don't need the large diameter. 1 millimeter is more than adequate to carry the ozone that we're going to be carrying for almost every application. And it carries up to a milliliter per second, so it's many times what we're actually doing here. So you don't need the thick tubing, and you certainly don't need this, except for you need the thicker tubing for silicone because it's had enough body that's not going to tear, kink, or disrupt flow. So the 1 millimeter silicone is pretty much out, so you're stuck with this, but you're losing significant. You're losing 20% from Teflon 1 millimeter to silicone 1/8 inch. It's 20% reduction, very significant. Hopefully that helps when you're making a decision about the tubing to use in your unit and how long the tubing should be. It's a very profound difference, and you need to be wise in the application that you're utilizing it for, and pick the right tubing, pick the right length, and pick the correct internal diameter to offer you the most accurate delivery that you can. Hope this was helpful.